we are going to learn about recursive language and recursively enumerable language. Now, a language L is said to be recursive if there exists a Turing machine that accepts all strings of L and rejects all strings that are not in L. So, if we say a language is a recursive language, then there will be a Turing machine for that language L. Now, if you give an input X to this Turing machine, this X will travel from the initial state to the final state of the Turing machine, and it will say it will be accepted. This will be accepted. This string X will be accepted by the Turing machine. So it will have, this X will have a path from initial state to final state, and it will halt and say that it belongs to this language. This X belongs to this language, and if that X does not belongs to that language, then it will have a path from the initial state to non-final state, to any non-final state, and it will say that it does not belongs to the language. So if X belongs to this language, then we'll have a Turing machine that will have a path from initial state to final state, and the Turing machine will halt. In both the cases, the Turing machine will halt by making itself stand in final state for those strings that belongs to L, and for those string that does not belongs to L, it will halt in a non-final state. So if we have such a Turing machine for a language, then that language is called as recursive languages. So now coming to the definition again. A language L is said to be recursive if there exists a Turing machine which will accept all strings of L and rejects all strings that are not in L. Generally speaking, this Turing machine will halt for any type of input. Now coming to recursively enumerable language, a Turing machine is said to be a language L is said to be recursively enumerable language if there exists a Turing machine that will accept and halt for all the strings that belongs to L, and for that does not belongs to L, it will not halt. Instead, it will loop inside the Turing machine. Say for example, if you have a language which is recursively enumerable, then you can have a Turing machine. Now when some X that belongs to this language is given, it will be accepted by the Turing machine, and the Turing machine will halt for X belonging to L. But if you're going to give X that does not belongs to this language, then the Turing machine will not halt, but it will go in an infinite loop, and it won't halt. Okay, the Turing machine won't halt for X that does not belongs to L. Okay, so for X belongs to L, it will halt. It will loop forever for X that does not belongs to L. Now, if that is the case, then L is called recursively enumerable language. So again, coming to the definition, a language L is said to be recursively enumerable if there exists a Turing machine which will accept and therefore halt for all the strings which are in L. Okay, that is, and it will loop for all strings that is not in L. So such a language is called as recursively enumerable language. Now if you are very clear with recursive languages and recursively enumerable languages, then we can have two more definitions, that is decidable language and undecidable language. Now we say a language is decidable language if it is recursive language. So we say a language is decidable if it is recursive. Now before undecidable, you have something called as partially decidable language. So a language is partially decidable if it is recursively enumerable languages. So here we say a language is decidable if it is recursive language. So all recursive languages are decidable language. All decidable language, and the vice versa is also true. decidable languages or recursively enumerable languages. Now coming to partially decidable language, if we have we say a language is partially decidable if it is recursively enumerable language. Okay. Now coming to the example of recursive languages, we say for example, if you are going to have a Turing machine for a power n, b power n such that n greater than or equal to 1. This is a language that is recursive language, because we can have a Turing machine that will have a path from the initial state to the final state, and that will have a path from the initial state to the non-final state for any string that does not belongs to L. So we can very well we can say this is an example for recursive languages. Now for recursively enumerable language, so all the languages, so example for recursively enumerable language, all the languages or any language that is generated by unrestricted grammar falls in the category of recursively enumerable language. You know what is an unrestricted grammar? It is type 0 grammar or phrase structure grammar. So here, so generally how it is different from context-free grammar. Context-free grammar will have set of non-terminals, and terminals any number of times. That is how we'll have in each production. That is context-free grammar. Okay, in unrestricted grammar, how we'll have? You'll have both terminals as well as non-terminals in the left-hand side, also terminals and non-terminals in the right-hand side. We'll have any combinations like this. This is what is unrestricted grammar. So any language that is generated by unrestricted grammar falls under the category of recursively enumerable languages. So whenever we say we call a language is decidable if it is recursively enumerable language. We say a language is partially decidable if it is recursively enumerable language. So if we have decidable and partially decidable, we'll have one more language, that is undecidable language. So if a language is not even partially decidable, then there will not be any Turing machine we can have for that language. There's no Turing machine exist for that type of language. All those languages fall under the category of undecidable languages. One such famous example for undecidable languages is halting problem. Okay, what is halting problem? The problem that given a string and given an input string x, check whether that x halts for a Turing machine. That is undecidable. Okay, that is what is called as halting problem. It was proved to be undecidable problem. Now coming to the summary, how can we summarize? So recursively enumerable languages will have Turing machine. The Turing machine will halt for recursive languages. Now for recursively enumerable language, the Turing machine will halt for those strings that belongs to L, and the Turing machine will loop for those strings that does not belongs to L. So decidable languages or recursive languages, partially decidable languages or recursively enumerable languages, and undecidable languages. For undecidable languages, no Turing machine exists. This is how we can remember all these type of languages. Thank you.